This process is complex, so let's step through it. First, it requires multiple proteins. There are lots of steps, and there are important groups of proteins and families of proteins responsible for the replication process. The process itself is important for survival. As an organism grows and cells divide, they replicate their DNA. It's also important for species survival because this DNA is the genetic information that's passed on to successive generations. To protect the information in the DNA, the replication must be accurate. That is, as it's replicated, there must be a very low rate of change in the sequence of bases. Another way to say that is to have a low mutation rate. This is important because changes in the DNA can impact the function of the encoded proteins and therefore the well-being of the organism. And like I mentioned before, this DNA is the template for reproduction. Even so, mistakes do occur, about 1 in 10 to the 9th nucleotides. That is, a DNA that is 10 to the 9th nucleotides long will probably have at least one error. What this says is that mistakes do occur. But mistakes have an upside in that they are opportunities for improvement. A single base pair change in a segment of DNA that encodes a protein might result in enhanced function of that protein, giving the organism an advantage. But on the downside, there are also the potential for deleterious errors. Sometimes a single base pair change might be catastrophic. So mutations do occur, but any given mutation might have an upside or a downside.